for us. And as Robin said, today we're going to be talking about a Coil story. And we just want to remind everybody too that, when you're talking about champion product, and that's kind of what this is all about, when you get the opportunity to talk to a customer, or if you're in front of a contractor or a customer and they want to know about coils and how come we use a particular coil and stuff like that. So we're going to be talking about some of those technologies today and actually covering, what we like to call a coil story. Next slide, please. So again, some of the coil technologies we're going to be talking about specifically will be tube and fin and microchannel, and we'll even touch on in a minute or two some of our competitors' coil technologies as well. Next slide. So in this presentation, again, we're going to do an overview of the different coil technologies, and we're going to talk to them and compare them and contrast some of those features as well. And so let's go ahead and talk at this time what the coil actually does in the refrigeration cycle as a quick review. Next slide. Okay, so let's talk about the function of the coil. So really, the role of any coil is to transfer heat energy. And one of the most important things from a service standpoint and from a sizing standpoint and from an airflow standpoint, those coils have to be absolutely clean if we hope to have proper performance of the equipment. And so as a quick review, we have hot gas coming from the compressor. Now, this is part of our basic refrigeration cycle, so it's kind of an overview of what we've talked about in some of our earlier sessions. But just as a quick overview again, the compressor, what it's going to be doing is going to be compressing refrigerant vapor into a hot gas. So off the compressor, we're going to have hot discharge line hot gas coming off the compressor. It's going to be going outside to the outdoor coil where it's going to be condensed. That hot gas is going to be condensed into a warm liquid as it rejects heat to the outside air that's passing through that coil. Now, this is an important concept, team, that the compressor, it's going to provide circulation in the refrigeration circuit, but what it really does is it's going to be transferring or moving heat from one area to the other. It's a critical part of the refrigeration cycle. So what happens, again, that compressor, it's going to compress cool suction vapor into a very high pressure, hot temperature, very high temperature, hot gas, and it's going to take it to the condenser coil outside. As that hot gas starts going through the condenser coil, it's going to start condensing from a hot gas into a liquid. I like to kind of think about like the old moonshiner still, if you will, where you have like steam and it condenses into water. It's the same kind of principle, except we're just talking about a different chemical that we call refrigerant. So as that hot gas goes into that condenser coil outside, as air passes across that condenser coil, it's going to condense that hot gas into a warm liquid. Once that warm liquid is achieved and produced in the condenser coil, it's going to move through the refrigeration cycle again. Down below, we see it moves through the liquid line filter dryer up to a metering device. Now remember, team, that metering device could be an orifice or it could be a TXV. It doesn't matter. They both have the same basic function. That metering device function is to spray and meter that warm liquid into the evaporator coil. So we're going to be spraying that liquid refrigerant into the evaporator coil. Now, team, please remember something too. Refrigerants are specialized chemicals that boil at a very low temperature. As a matter of fact, if I was to take a Pyrex cup or an insulated cup and put our 410A refrigerant into it and just set it on my workbench and take a thermometer and stick it in there, I would notice that R410A in that Pyrex cup on my workbench would actually be boiling at about 60 below zero at atmospheric pressure. So it's a specialized chemical that boils at a very, very low temperature. So what we're doing, we're going to be spraying that liquid refrigerant into the evaporator coil. And as that liquid refrigerant passes through that evaporator coil, it's going to start boiling that liquid off. And as it boils it off, it's going to absorb heat from the indoor air passing through that coil. So that liquid refrigerant boils off inside that evaporator coil. In fact, it's kind of why they call it an evaporator coil, evaporator coil. It's evaporating or boiling that liquid refrigerant off inside that coil. And in so doing, it absorbs heat from the air going across that coil. Now, at normal suction pressure, that liquid refrigerant is boiling inside that evaporator coil, at about 40 degrees Fahrenheit. And so that's just one of the characteristics of refrigerants. As the pressure changes, the boiling point changes as well. So at about 130 pounds of suction pressure, give or take on what we call the suction line, or the low side of the system, that liquid refrigerant is boiling inside that evaporator at about 40 to 45 degrees Fahrenheit. So once that refrigerant boils off, once that liquid boils off into a vapor, that cool vapor goes down the suction line, which is a cool gas. Now it goes down the suction line back to the compressor, where it's going to be recompressed into a hot, high temperature hot gas again. As we kind of look at our basic refrigeration graphic there, we see the normal flow is compressor to the condenser, liquid going down the liquid line, going through the metering device as it sprays that liquid refrigerant into the evaporator. It boils it off, then that cool gas goes down the suction line back to the compressor, and that's the basic refrigeration cycle. That's what those coils are actually doing. They're actually moving heat and absorbing heat on the evaporator and rejecting heat on the condenser coil outside, where we can get rid of that heat outside. Any questions or comments on the basic function of the coil in our refrigeration circuit?
Hey, Joel. Just one point. So I know you talked about, clean coils are necessary, but
Absolutely.
what are some ways to prevent, or how do we make sure that we have clean coils?
That's a good question, Emily. So basically what I always recommend is that every year a person has, a homeowner or a person has their contractor come out or their service technician come out and clean those coils. And so just nice, clean, fresh water to clean those coils. And there are some coil cleaners out there that you want to be careful. You want to make sure you use coil cleaners that aren't corrosive, but clean those coils at least once a year. And the best thing a homeowner can do is to change those air filters inside their home at least every couple or 3 months, depending on the type of air filter technology you have. So that's the big thing, Emily, is to keep those coils clean, and to change those air filters inside is the best thing a homeowner can do to keep those coils clean and to keep clean, fresh air going across those coils. Good.
Is there any other factors that might play into it, whether it's like maybe the homeowner might have pets or they have allergies?
Sure. And those are all serious. They can be serious considerations. And some of those are some indoor air quality things that we could talk about in another session. But basically, what you want to keep those filters clean. And if you have allergies, or if you have pets or anything like that, you may want to have a higher, what we call MERV, which is a type of rating, a higher MERV rating on that indoor air filter on your air handler or furnace, to help catch some of those particulates and to help remediate some of those indoor air quality concerns, especially if you have asthma or allergies or things like that. Good. Any other good questions or comments on the basic function of the coils and why it's so important to keep them clean and how they're working in the refrigeration cycle?
Joel?
Yes, sir.
I wanted to mention that as the MERV rating goes up on the filter, you can decrease airflow, which if you decrease too much airflow, you could have an issue.
Oh, I love that. I love that comment. That is correct. So based on the filter technology, to your good point, based on the filter technology, we may have to have larger return air ductwork. We may have to have more return air registers and stuff like that. So absolutely, on the indoor coil especially, we want to make sure that we maintain the proper airflow across that coil. And the higher the MERV rating, or the more filtration that you have on that air that's going through that coil, we want to make sure to have plenty of extra return or larger return. So those are serious considerations when you're looking at utilizing, especially some aftermarket, media filters and stuff like that. Good, excellent point. Thank you for that good input. Any other good questions or comments?
Well, Joel, I know we also in past presentation talked about heat pumps.
Yes.
So the presentation that we're looking at right now is really based on an AC versus a heat pump, correct?
That is true. But you know what, Emily, I like the way you think about those things. But the truth about it is, it doesn't matter if it's a heat pump. It doesn't matter if it's a straight cooling unit. Doesn't matter what mode it's in, because that coil is still going to do the same thing. The cold coil or whatever coil is acting like the evaporator. For instance, on a heat pump, the evaporator coil is going to be outside in the heating mode and inside in the cooling mode. And vice versa. In the heating mode of operation, the heat pump, the condenser will be inside, so to speak, and the evaporator will be outside. So it really doesn't matter what mode of operation we're in. Those coils are going to work exactly the same, whether they're a cold coil or a warm coil. The warm coil is going to be rejecting heat, from the hot gas of the compressor, and the evaporator coil is going to be boiling liquid refrigerant into it. And again, the coils actually swap function in a heat pump, but the principle's the same. Those coils have to be clean, and that the sole purpose of those coils is to transfer heat energy, whether it's an evaporator or a condenser coil, as we discussed. Good comment. Any other good comments on the function of the coils and how they work in the refrigeration cycle? Okay, good. Next slide, please.
You should have control, Joel.
Oh, I don't.
You don't?
Nope. Let me try.
Okay.
No, I don't. So let's go ahead and just go next slide.
Okay.
We're gonna let you be the slide monitor today. Okay, so let's talk a little bit about some coil types, team, as we look at some of the basic coil types. Now, at the very, very bottom, I pulled this picture off of Google, actually. And what it is what we call spine fin coil. This is a coil technology that's been around a long time, since the General Electric days. As a matter of fact, this type of coil was actually patented back in 1959 by General Electric. And what it is just basically a tube with a spine type of fin wrapped all the way around that tubing. Another type of coil technology that we'll see up in the upper left-hand corner is what we call microchannel. Now, microchannel, we're going to dig into microchannel a little bit deeper in our presentation today. But basically, microchannel, I want you to think of it just almost like a radiator. And so it's the same type of material that you'd see in like an automotive radiator or an oil cooler or a transmission cooler on an automobile or a truck. As a matter of fact, on my airplane, we use microchannel type of technology on my oil cooler, on my engines on my airplane. So microchannel is a very, very well-known technology. It's a very compact type of technology and material, and it's very, very simple. It looks, like I said, it kind of looks like a radiator because that's the type of technology that utilizes microchannel. And then finally, in the upper right-hand corner, that's kind of a conventional, what we call tube and fin. And as its name implies, we actually have tubes that are going to be swedged or mechanically affixed to fin material. And as we take a look at that, we see that there's actually a bunch of tubes that pass through some fins. And we'll talk a little bit more about that. But so tube and fin, spine fin, and microchannel are some very, very common coil types that we're going to be finding out a little bit more about here shortly. Please, everyone, put this in your back pocket. One of the things we want to stress, though, on microchannel, at Johnson Controls and our Champion product, we only use microchannel on straight cooling, air conditioning, condensers only. Let me say that one more time. Straight cooling, single stage, cooling condenser coils only, because microchannel is not the proper technology to use for the indoor coil. And again, we'll discuss that and expound on that a little bit more later. Same way with spine fin. Spine fin is not designed to be on the indoor coil. That's strictly an outdoor coil type of technology. Next slide, please. Okay, let's talk a little bit about our Max Alloy A coil, our new A coil that's coming out. Actually, we've started getting orders and stuff already for now. We've gone back to an A coil. And an A coil, as this name implies, just looks like an A. And this coil technology has been around a long time. It's actually the preferred technology as far as configuration. We've had some different coil configurations over the years, but we have returned back to the A coil. And the Max Alloy coil specifically, let's talk a little bit about that. That Max Alloy coil is an indoor coil, and they're designed to be installed with our furnaces, and they come installed in our one-piece air handlers. So this Max Alloy coil, they're actually part of a matched and engineered air conditioning or heat pump system. So this is something I like to stress. You can take a an aftermarket coil and make it work perfectly fine with our product. As a matter of fact, we do have some aftermarket coils that work fine. You can have other manufacturers, they may have a copper and aluminum type of coil configuration. Again, that was kind of the standard, for a long time in the industry. But I'll tell you, the Max Alloy coil is an all aluminum coil. And some of the advantages of that specifically is a tremendous reduction in the potential for corrosion, because what you're looking at is you're looking at a coil that has aluminum fins, aluminum tubing, aluminum end plates. As a matter of fact, anything that's going to touch condensate, with the exception of the drain pan, is going to be aluminum on aluminum. So that's significant, especially if you have a corrosive type environment. And one of the most corrosive environments that you'll find are places like hair salons, for instance. If you have hair salons, they'll eat a coil up like crazy. And so aluminum on aluminum, aluminum coil, aluminum fins, aluminum end plates, and so on. Aluminum on aluminum is just a lot more reliable. And the Max Alloy specifically is a very, very tough and corrosion resistant material. In addition, some of the key features of our coil that I'd like to talk about in our cased coil example. Was there a question out there real quick?
Oh, there was going to be a comment, Joel.
Sure.
I was going to say, I know you're talking about fins and hairpins. Just for like kind of a visual, if you look like behind the number 6, where the area is going up and down, that would be considered a fin area. That's the pieces that are stacked together. And then also, if those don't understand what a hairpin is, it's kind of similar to when we talk about a hairpin that you can use in your hair, but it's lacing and it's going through the coil, but it's just a loop that's going all the way through. And so that would be behind that number 6 area as well. You can kind of see where those pieces will be kind of coming out, and they put the U-bends on there. But
sure.
That, I figured we might want to kind of mention that if you don't have people familiar with that technology.
Yeah, so like Emily said, if you kind of look at our cursors there at around number 6, you'll see these tubes here that kind of turn, and what those tubes actually go inside the coil, and those tubes, on the tubes themselves, there's going to be fins on there, and as air passes across those fins, it's going to exchange heat energy with the fins and the tubing, and then the refrigerant inside the tubing. So this evaporator coil that we're looking at is like we were talking about in our basic refrigeration cycle. You've got liquid refrigerant that's going to be sprayed into this coil. It's going to boil off and then go back on this suction line, number 5, back to the compressor. So this coil right here, as Emily was saying, is actually constructed of tubing and fins and those hairpins where they actually turn. We have all those multiple turns where this coil has got refrigerant passing all through those tubes and then back out this number 5, this suction line going back to the compressor. Good, excellent. And so in our cased coil example, just some kind of key features I'd like to talk about. We have these new integrated duct flanges for ease of installation. Up here, number 1, you can kind of see my cursor. In addition, down below we have what we call an even flow. It's a new distributor design. Now, the distributor, what that is, that's actually part of the coil where the expansion valve or the orifice is going to be placed. That's going to be spraying that liquid refrigerant. As a matter of fact, if you look closely on the screen there, if you watch my cursor where number 2 is, you see these little tiny tubes coming off this distributor down here. And those little tubes are actually going to feed refrigerant into the individual coil passes as we take a look right here at that distributor. So that improved distributor design is going to give us a better distribution of refrigerant into the coil passes and a more balanced refrigerant flow. So that's what that's all about. If you take a look up here on number 3, bullet number 3, we have some improved insulation design as well. It's a single piece of insulation that's glued in place and no exposed edges anymore that we may have seen in some of our previous products. So this new improved insulation is going to be a real winner too, I think, from an insulation standpoint and from an efficiency standpoint. Now let me have your attention back on number 4 again, kind of down there where the distributor is. This is where the TXV or the piston is bolted in to that distributor number 2. So as you take a look at that photo, this is actually where the expansion valve or the TXV will be bolted in. And so it's really kind of neat, because what's going to happen is that bolt-on TXV does not require any sort of brazing or any sort of welding or anything like that, and it provides very, very easy installation. The other thing I really like to talk about real quick is the fact that we've reduced the number of expansion valves or TXVs on our new coil design from 8 down to 2. And I'll tell you, that's just great news, because literally 2 expansion valves now from from 1.5 all the way to 5 ton, we were able to design in just 2 expansion valves across the entire product lineup. So I think that's some really, really good news. And from an installation, yes, go ahead.
Yeah, to speak to that, so there's different sizing of TXVs based on the outdoor unit. Why would we have different sizes? Why would we have 8 or 2 different TXV coils?
That's a really good question. So in our previous product, we had like up to eight different expansion valves. And what it had to do with the matter of the coil design and how that expansion valve was spraying that liquid into that evaporator coil. And so, through our test procedures and stuff like that, it ended up we had several different expansion valves for the different tonnages of unit. So a 2-ton unit might have a different expansion valve, for instance, than a 1.5 or a 2.5-ton unit. But an expansion valve, this is something interesting and unique about an expansion valve, Emily, is the fact that it has a very, very wide and broad operating range. And so that's just one of the characteristics of an expansion valve. It has a very wide operating range as far as tonnage or capacity. So what we've done with our new coil platform is we've been able to narrow that down to 2 expansion valves that's going to cover the entire tonnage range from 1.5 through 5 ton. So because of that operating window, if you will, on an expansion valve, we may have a 3-ton expansion valve that's actually able to screw down to 1.5 tons and maybe screw up to 3.5 tons as an example, because of the wide operating window on that expansion valve. And likewise, we might have a 4-ton expansion valve that can screw down to 3 ton or go up to 5 ton. And so that's kind of how that works with expansion valves. Now, pistons, on the other hand, are going to be very, very specific size pistons. If you have like a straight cooling application, 13 SEER in the northern regions, where you're going to have a particular piston size based on the tonnage of the outdoor unit. But expansion valves, very, very wide operating range. That was a really good question. Any other good questions or comments?
So Joel, on that, our new coils, the 3 through 5 ton will be the BC TXV, and anything under the 3 tons, so 1.5 to 2.5, will be the BA TXV.
That sounds right, Emily. That is correct. And again, the reason we can do that is because of the new even flow distributor design. We have better flow in the throughout the coil, refrigerant flow throughout the coil, and because of the characteristics of an expansion valve, it gives us that flexibility of a wide operating window, to your good point, from about 3 ton down to 1.5 tons, and then the other expansion valve, for the larger tonnages. So good, that's great news. Another neat thing about our new max alloy coil that I really like is the fact that we have copper field connections. So this is going to make it easy for hookup with our refrigerant line set right there, number 5, that bullet number 5, for easy installation for the guys out in the field. So basically, they're not going to have to worry about having to try to braze or learn how to weld or braze aluminum, because this copper stub out, that little number 5 on the bullet right there, what that is, it's a copper stub out, and the field technicians and the installers are used to brazing onto copper. So that makes it very, very easy for installation. And we've already talked some about the max alloy coil being aluminum, all aluminum coil built to deliver that lasting performance with high efficiency and reliability. And then finally, the one last thing I'd like to talk a little bit about with our cased coil in our example today is our thermoset drain pan. That thermoset drain pan, it's never going to rust, and it's going to clear condensate quickly for improved IAQ. Because remember, team, you don't want that condensate water sitting there in the drain pan, because if water's sitting in the drain pan, it can collect, dirt and mold and those types of things. So it's important to get the condensate off the coil and get it down the drain line where it belongs. And our thermoset drain pan, again, it never rusts, it never corrodes, and it clears that condensate quickly for improved indoor air quality. Any questions or comments? Any more questions or comments on our Max Alloy A coil that we've used in our example as one of our coil technologies?
Joel?
Yes, sir.
Right there where the number 5 is, right there where you'll be brazing or soldering on.
Yes.
I had a local York dealer warn me that you're now brazing closer to the valve than you were with the older coils.
Okay.
And you have to watch heat. One of their valves theirs was leaking after they did their brazing. It was because they had too much heat on it. So
okay.
They weren't used to the valve being so close to the braze point.
That's a very good field observation and technical point. One of the things I always like to do whenever I get kind of close to components like that, I like to use wet rags, or I like to use like heat paste and those types of things. So definitely use some heat sink compound, anytime you're in doubt of possibly damaging another component. The other thing I like to do is to make sure, and I don't like a turbo torch for welding these up, using like your 15% silver brazing alloy. I like an oxygen acetylene torch because you can get there, get the heat on it quick, and get the heat off quick, very, very quickly. And so that's my recommendations, is to be sure and, use a torch with enough heat source, like an oxygen acetylene, to get the heat off and on quickly, and then use those wet rags or use, heat paste compound for any of those sensitive components that may be affected by that heat saturation on that copper line. But that's just a great, great field tip. And we need to definitely watch out for that, during our install, is to keep from overheating those critical components. Thank you for that field tip. Good.
And Joel, I know we had a question. Josh had asked, are they going to be extending the stub outs for press-on fittings? And I'm not sure about the length. I know in the past, when we designed the past coils, we really tried to watch the spacing on those, because they could get field damaged by the way that when we're shipping them, or even like if it sticks out too far, it could get caught on something. So they've tried to watch that. So there's definitely a balance that we have to have there. They originally had planned to have a soft solder cap so that it would help. You wouldn't have to, it would be a little bit easier instead of having to rim out for our conventional brazing. But I don't know how these new coils are for the press-on fittings. Have you heard anything on that, Joel?
I haven't, but I will say that our last technical conference we had, that was actually a subject, one of the kind of side subjects, contractors and some of our wind supply locations that had come to the technical conference. Some of our local folks had asked us about that, and to your point, Emily, the real consideration is if you get them too long, they're going to get bent, they're going to get damaged during shipping and packing and all that kind of stuff. And I'm not 100% sure if we've endorsed, the press-on fittings yet, to be honest with you. According to some of the factory folks that I talked to during our technical conference, they were in the process of testing some of those materials and systems. But to my knowledge yet, the only recommended method of joining any of our refrigerant lines, to our indoor-outdoor units is by brazing. That's the recommended method of hooking them up.
Joel, I know we did have a white paper, I believe, that said if they did do the press-on fittings, it would not, they would not lose their warranty, but the brazing method was the preferred recommendation.
That does sound correct, Emily. Like I said, it's the press-on fittings are getting more and more popular and well-known and tested. I frankly don't have a problem with them using a press-on type of fitting, as long as it's quality refrigeration grade, or brazing are the methods that that we recommend. Good. Yeah, excellent. Okay, next next
Joel,
slide. Yes.
There was, Michael had a great comment. We have had guys who have been using press ACR, both NIPCO and Vega jaws are different, but haven't had any leaks / complaints. So
Oh,
thanks
that's
for
great.
that.
Yeah, thank you, Michael, for that great input. You know, and that's one of the things with our training sessions like this. You know, I love to hear those field inputs, so please keep that up. That's good. That's good intel from the field. Thank you. Okay, next slide, please. All right, so let's talk a little bit about microchannel. Microchannel is again, if you look at it, it kind of looks like a radiator technology because that's really where the technology came from. But microchannel, you know, let's talk a little bit about what it is specifically. It's an all aluminum high efficiency heat exchanger. And one of the neat things about aluminum on aluminum, and this goes with any all aluminum heat exchanger, you're going to have minimal galvanic corrosion. Now, when we talk about galvanic corrosion, we're talking about corrosion that occurs between dissimilar metals. So if you have a steel and a copper, you know, end plate on a coil, or if you've got like aluminum on copper, you have two different types of metals. And anytime you have two different metals coming together in the presence of moisture and other, you know, potentially corrosive environments or corrosive agents, what can happen is those two different metals are going to react with each other, and then we call that galvanic action or galvanic corrosion between them. So you're going to have minimal or no galvanic activity between the fins and the tubes compared with copper and aluminum because it's all aluminum. So again, one of the great things about an all aluminum type of coil is you're going to reduce that galvanic or that bi-metal type of corrosion. So as you take a look at the tube and fin, you can kind of see that you've got these little tiny micro channels, if you will, where refrigerant's going to be passing through. It's a smaller size, it's lighter weight. You're going to have lower charge. You're going to have less charge in the system. And you're going to have a more efficient system due to less refrigerant circulating throughout the system. So I want you to think about it. The more refrigerant that we have circulating throughout the system, to move that liquid refrigerant throughout that coil, the more refrigerant you have in the system, the more work that compressor has to do. Because remember, it's pushing that hot gas and pushing that liquid through the condenser coil, pushing it through the metering device. That compressor has to provide a pressure differential to push it through the filter dryer and then suck it back through the suction line. And so when you think about it, you know, if we can reduce the amount of refrigerant in the system, we're going to have a more efficient system. It's going to be a lighter weight coil. You're going to have a lower charge or less charge in the system and still get the work done and have a more efficient coil. So where we actually use microchannel coil is going to be on single stage air conditioning condensing units only. Let me say that one more time. Single stage air conditioning condensing unit only outdoor coils, because microchannel is not the right technology for evaporators because it doesn't shed water properly. It doesn't allow condensate to drain properly off that coil. And so we do not use it on indoor coils, and we do not use it on heat pump outdoor coils, because remember, team, on a heat pump, in the heating mode of operation, that outdoor coil has to go through a defrost cycle on a heat pump. And so we have to drain water off of it. So anytime you're draining water, or you're trying to manage condensate or water coming off that coil, that condensate, you want to use a tube and fin because it's superior technology for draining water off the coil. But if you have a coil that's a straight cooling application, AC only, you're not going into a heat pump cycle, you're not draining, you know, water like during a defrost cycle or anything like that. Microchannel works very, very well, very efficient coil for AC only condenser coil applications. As a matter of fact, since 2004, we have over 9,000 units in the field with microchannel coil. And you can kind of look at some of the cutaway and you look at it and say, wow, that kind of looks like a radiator, because it's that same type of technology with the microchannel inside. Any questions or comments on microchannel so far before we dig into some more things about it?
Joel, are these used in our commercial units as well?
Absolutely. That's a good question. So But again, Emily, straight cooling, air conditioning only, straight cooling application, condenser coils only. Good, excellent. Next slide, please. So as we kind of look at that refrigeration cycle again, we see we've got a compressor that's pumping hot gas into a condenser. And that condensing section is going to take that hot gas and turn it into a liquid. Now watch this though, team, on a microchannel coil, and again, AC only application, that hot gas is going to pass through about half the coil. And as that hot gas passes through about half the coil, what's going to happen, that portion of the coil is going to take that hot gas and turn it into a liquid as it condenses that hot gas. But hang on a second, the other half of the coil, we're going to take that liquid and we're going to cool that liquid down some additional amount. And we call that subcooling. So unlike a tube and fin where you've got all these different tubes going around and collecting the refrigerant together and then subcooling it the last 2 or 3 passes at the bottom of the coil, microchannel, about half the coil, the upper half of the coil, is the condensing section where it takes hot gas and turns it into a liquid. And then the lower half of the coil is piped around in such a manner that what it's going to do is going to subcool that liquid and provide extra heat transfer to cool that liquid down before it goes down the liquid line to our metering device and spraying it into the evaporator. And then you can kind of see the refrigeration cycle. We've kind of animated that again for you, but we just wanted to kind of talk a little bit about microchannel and the fact that it's a little different application, but it's still a condenser. It's just that it's a very, very efficient condenser compared to some other technologies. Any questions or comments so far on the microchannel coil? Okay, well, next slide, please. So some of the advantages of microchannel. Let's talk a little bit about some of the talking points. Contractors may ask you, well, what about microchannel? What's so good about it? As a matter of fact, I know it's a little bit more critical with charge and it doesn't hold as much charge and so on. And and sometimes that can be kind of a negative conversation, but really it's a wonderful story to talk about. Microchannel is a great technology. As a matter of fact, some of the considerations are the fact that we fix both ends of the coil to add additional rigidity or firmness to the coil. It helps eliminate stresses due to a shifting coil, in the cabinet. It also reduces corrosion complaints due to an all aluminum coil. And again, I want to stress microchannel is aluminum on aluminum. It's an all aluminum type of coil. You're going to have improved liquid refrigerant subcooling, as we talked about, due to that microchannel design. Half the coil is going to be used to de-superheat and to condense that liquid, and the other half the coil is going to be used to subcool, so it's very, very efficient. And finally, microchannel type of coil technology is used and well known in many non-HVAC applications. Automotive radiators, for instance, are a type of microchannel, aircraft oil coolers, transmission heat exchangers, and so on. So it's a very, very known technology. It's a heavy duty aluminum, all aluminum coil. Good technology for AC only condenser coil application. Next slide, please. So as we take a look at, we talked a little bit about the refrigeration cycle and how it's efficient, but let's talk a little bit about some of the other things that we do with microchannel in our testing procedures to really, torture these things and see how they work, in a real corrosive environment. So the SWAAT, the SWAT test, it's a saltwater acetic acid testing laboratory test. And what this is a fast test to rank different types of systems compared to each other. Now, specifically, it's going to be used as an industry standard, and that industry standard B17 is actually not severe enough to adequately test microchannel. These are some tough coils, people, I'll tell you. We have some of these down in our Battelle, Florida Materials Research Facility at our field test site right down on the coast. And this happens to be a level 4 coastal environment, which is one of the most severe in the United States, right down in Myrtle Beach area, if you want to get technical down that way. But this is an accelerated corrosion test site that we use right down on the beach to really test different coil technologies. Next slide, please. And so here's another picture of it. And so here we've got units that are actually located on the roof of a large beachfront condominium. And 412 of these units with the new alloy systems have been installed since 2012. They're uncoated coils and routine inspections. You know, we look at it, we routinely inspect it. And again, we've got different coil technologies down there, microchannel as well. Next slide. And so as you take a look at some of the things, you know, that are being done with, you know, different coil technologies down there, it's specific to a coastal area. One thing is very, very important. All types of heat exchangers require routine cleaning for performance and reliability. This kind of takes us back to our original slide in the beginning of our presentation. Keep those coils clean and you're going to get a lot better performance out of it. And it really doesn't matter, you know, what kind of coil technology you have. You really want to clean those coils at least once a year, indoor and outdoor coils, for optimal performance. Now, tube and fin designs continually and gradually lose cooling capacity as those fins start corroding and falling off. You can kind of look at some of these pictures here. These are tube and fin coils that we're showing right now. They're almost rotted away at the test site. Literally after a year or two, these tube and fins, the fins are actually starting to fall and flake off of the tubing because of the fin corrosion. Now, routine cleaning for reliable long-term operation is important, again, for any coil. But microchannel holds up better than tube and fin designs, especially in these corrosive environments. So we've talked a lot about, you know, microchannel advantage as far as efficiency and heat exchange and less circulating refrigerant. Those are all top things. But also they're very, very corrosion resistant compared to other like copper and aluminum fins, you know, that we can see kind of in our test facility here. Those tube and fin type of coils they're literally just flaking and falling apart. Any questions or comments about microchannel and some of the cool things we've talked about with that technology before we continue with our training today? Any questions or comments? Okay, next slide, please. When it comes to repair, one of the things that I hear quite a bit, you know, from the field on occasion when I talk to contractors, that they think they don't like microchannel. The truth about it is, from a serviceability standpoint, microchannel, the best thing to clean the coil with is just use medium pressure water to clean. You don't really need coil cleaner or anything like that. But if you do use a coil cleaner, make sure that you use a coil cleaner that's compatible with aluminum. We don't want to use corrosive coil cleaner, so make sure that whatever coil cleaner you're using is compatible with all aluminum coil. And again, we recommend don't use cleaning solutions or pressure wash, just plain water. You know, just wash the coil with plain water. And in addition, if you have to repair the coil, you know, let's say, for instance, it got shot with a BB gun, or you had some damage from it, you know, a lawnmower hit it or a rock came up and hit it, you can actually repair it using our service kit. And there's a number of it right there, and a MAP gas torch. So just a real low flame with a MAP torch. It doesn't have to be like oxyacetylene. And so what you're going to do, you're going to clean that coil really well. And inside this service kit, you know, 327-8301 service kit, the Source One service kit, what it's going to do is it's going to allow you to take this. It's a type of low temperature solder almost. And what you're going to do, you're going to heat up the area. You're going to clean it real good with the wire brush, and you're going to heat it up, and you're going to clean that area. And then you're just going to seal it off with that solder. Because remember, team, microchannel has so many multiple passes. Even if you block off, you know, 4 or 5 or 6 or 8, you know, little microchannel passes in there. When you make this repair, it will not affect the coil's efficiency. It will not affect the system's pressure whatsoever. And it's a very, very straightforward repair if you need to repair microchannel. Any questions or comments? Now, Emily, I'd like you to pop in a little bit right now, because you've actually done this before, haven't you?
Yes, that was one of my first trainings when I came on back in 2011. It was supervised, but I had the opportunity. It's my first time using one of the torches, but I was able to go in there, and you just kind of feed some of that solder, like Joel said, and it closes off and seals that hole. So it really was not that difficult. once you got the hang of it.
Yeah. And that's been one of the things that contractors in the field say, oh my goodness, I can't fix it. I can't do it. Well, the truth is we've got a simple little kit. Just take a map torch and clean that coil where it's messed up, and you can actually repair a microchannel very, very easily in the field, with the proper materials. Next slide, please. Okay, so that really concludes our basic HVAC story. So what I like to do at this time is, of course, want to thank everybody for training with us today, but also let's open the floor up for a few minutes for any questions or comments. I'm going to turn my camera back on because I always like to answer questions kind of face to face, if you will. So let me turn my camera back on and we'll go ahead and address any questions or comments that we have on the training today. We hope everyone enjoyed it. But let's open the floor up for any final questions or comments on our training today with our basic coil story. Everybody good?
So Joel, I'll throw one out for you.
Sure.
We talked about what applications we typically use the microchannel in for the outdoor units, but is there a difference on the different sizes? Does it do better in the smaller or larger size units?
That's an excellent question. To my knowledge, microchannel, again, straight cooling, single stage application like we were talking about. It's good. It's good for, it's just a good coil technology. And I don't really know if there's any advantage of tube and fin specifically over microchannel, in straight cooling application. What's your comments on that? What prompted that question?
I think if you look at the size of our units when we have some of the small, so say like your 1.5, 2 ton versus a typical tube and fin, we have some advantages being able to get into some small applications.
Oh,
and even
smaller footprint.
sizing.
Oh, okay.
Yeah.
Physical sizing. I thought you were talking about capacity wise, but physical sizing, smaller footprint. Yes, microchannel does lend itself well to smaller cabinets and smaller footprints, physically smaller, because of the efficiency of the coil. Yeah, that's right.
So some of the things that first come up is maybe a row home where you literally have to take the coil through the house or the condenser through the house. Being able to have microchannel has that opportunity to actually take it through the house to the backyard or wherever it needs to go. Or even in some tight applications where you've got some multifamily and you have to put a bunch of them next to each other as you're replacing maybe a 2008 unit. Those were a lot smaller versus going into the higher efficiency we're seeing today. If we have the microchannel, we can still get about the same amount of units into that smaller space.
That's an excellent point, Emily. Good. Excellent. Yeah. Any other good questions or comments before we conclude our training today on our coil story?
Joel, so I will do another one. We did have, when we first came out with the Max Alloy, I'll put in the comments there for our participants to see how the units are actually built. It walks through the story, and so it's kind of fun to see how they're doing the Max Alloy coil. Obviously, it was an N style coil, and now we're going back to A, but it's still very relevant, being able to talk about the aluminum to aluminum. So you'll be able to go out to the Champion YouTube channel and see the kind of the progression on how the unit's built.
Cool. Thank you. Well, fantastic. Robin, are you still with us?
Yes, sir.
All right. Any final comments from you, Robin, today before we conclude our training?
No, just want to thank everybody for joining us.
So I'll do one more, Joel. Sorry.
And
so when we go ahead.
Just a quick reminder now, what we'll do is we'll be posting this out on our YouTube training channel. and we'll be calling it HVAC Basics, a Coil Story, and today's date 07/13/2022, and we'll have that out on the YouTube training channel here probably in the next day or so you can review this as many times as you like. Go ahead, Emily. What's that final question?
All right, so we earlier talked about spiny fin, and I know so what are, like, it sounds like there's really only about 3 different outdoor AC coil technologies. Is that correct?
Yeah, and I mean when you get into some refrigeration applications, you get into like water type heat exchangers, but from an air to air type of heat exchanger technology, microchannel tube and fin and spine fin are probably the predominant technologies out there, at least in the HVAC world. That is correct.
And for spiny fin, that's a trademark for the Train Corporation, correct?
That is correct. So
For
spine fin,
Ingersoll.
yeah, spine fin coil was invented in 1959, and General Electric, they started winding it on special machines down there in Tyler, Texas, and they still use those machines. So this technology has been around a long time, but to their credit, spine fin is very efficient because you have a lot of surface area on those spines, those fins coming off. And so it is a good coil technology. The only real challenge with spine fin is cleaning it, especially if you have like cottonwood or you have those types of particulates, real stringy or grainy type of things. So they've got some particularly unique applications and recommendations for cleaning spine fin. But like I said, I can't beat them up. It's a good technology. It's just a little different than what you see with other manufacturers typically.
And another consideration I know is when you have to repair that outdoor unit. I believe in their installation or their tech guide instructions is they actually have you remove the coil to be able to get into the compressor.
That depends on the product that you're looking at specifically. So, typically
it's in a circle. There is no breaks in it.
Yeah, typically that is correct. So, from a serviceability standpoint, our champion product, we have that corner access for the electrical, as well as all the compressor and components are in that corner access. So some of the downside of other coil technologies from other manufacturers is you have to remove the top and the fan and the grill and all that stuff to get the compressor out if you have to service the compressor. So that is correct. That's definitely a consideration. Good. Excellent. Well, team,
those are I'm just going to throw a little promo out there. Those are some of the things that you will be able to go and discuss through one of our ducted system training that we have. I know Robin had a chance to audit one of those classes, but they do go into tearing down and seeing the serviceability of all the different equipment in the field, as well as getting a chance to get their hands on it and see that. So we do have an opportunity to come in and check out the competition and do kind of that side-by-side training right there. And we also, I know Joel has some plans in place for the future to do some on-site and in-person training as well.
Yes, and once we get some travel opened up and stuff like that, I look forward to maybe getting to the factory and hosting or being part of some training sessions, some hands-on training sessions, with our new TSM group and those that would visit the factory and take advantage of some of those opportunities. Absolutely.
And Robin, you're going to have to refresh my memory. It used to be the TM teardown, but I know that was just part of the training. Do you recall what the training is called now?
The TM boot camp.
So that I don't know if that had the teardown aspect. Is that the one that you audited?
No. I can't remember what the one was that I audited. It's like product essentials. That's what it was.
There you go. Product essentials. Yeah. So if you have someone new to the industry or even some veterans, I think product essentials will be a great opportunity to do some in-person training with our Ducted Systems Academy.
Fantastic. Okay. Well, team, thank you very much for the opportunity to train with you today. It's as usual, it's fun to do this type of training. Please, we look forward to to having you back, everyone on this call. And Emily and Robin will be sending out information and communication concerning our next go round, some of the next subjects and stuff. But if there's no further questions, thank you again for training with us today, and have a great day and be safe out there.
Thanks, Joel.
Thank you.